Good morning. Now welcome back to the session. Last time I explained you about the association rule, and again I am just repeating for the sake of repetition, and then we will take a algorithm. So we have transaction ID 10, 20, 30, 40 like we did last time, and then the items bars are shown here, and then there is a Venn diagram. So that means some people buy this product, some people buy this product, some people buy this, and some of the people will going to buy some of the products together. So we can use our set theory for doing the analysis. So for example, we have support and we have confidence, which you have already seen last time too. Now what we say that suppose the items are very big, number of transactions are very big and the items are few, or items are very large and number of transactions are few. So how to deal such kind of interestingness? So let us see what we do. So additional interestingness measure can be applied to the discovery of correlationship between the products. Okay, a major challenge in data mining item set is a large data set. That is a fact that such mining often generate a large amount of data set or item set satisfying the minimum support concept. Okay, and if the minimum support is set low, then I'll have many number of transactions which are going to show you. So a long item set will contain a combination of shorter frequent sub item set. For example, a frequent item set of the length 100, okay, such as A1, A2, A3 up to A100 will contain 100 by 1 frequent item, one item set. So if people are buying 100 number and each one is buying only one item, then I have 100 frequent one item set as A1, A2 up to A100. Okay, then if I have two item sets, so I'll have two item set, so A1, A2, A1, A3 and this thing and so on. So the total number of frequent item set will be very large. So if we take 100 one item, 100 two item, or 100 by 100 item. So if we go on adding the total number of item set is shown here, then roughly it comes to 2 raised to power 100 minus 1, or approximately equal to 1.27 into 10 raised to power 30. Now this is very difficult to manage, very difficult to realize and very difficult to implement too. So what shall we do? We go for a closed pattern, maximum pattern. We try to reduce the pattern and we try to have a sub pattern. So solution is a long pattern contain a combination number of sub pattern like A1 up to the, and may contain 1 by 100, 200 and things like that. So solution is mining a closed pattern and find out the maximum pattern which are available, and if it is closed, the item set X is said to be closed if X is frequent and there exists a no super pattern. So for example, I have bought 3 item and 3 item set, and there is another example where I have bought around 5 item set, where 5 item set are the superset of the 3 item set. So there is a set theory, I hope every one of us know. Okay, so we can define the superset and things like that. Okay, so closed item are what you call as the last compression of a frequent item set. Now let us see a example and let us try to learn a okay. Now let us see this example, and this example is what we call as a priori candidate generation and test approach algorithm. This is very important in data mining, and what this algorithm is, I'll explain through the example, then I'll go to the theory part. So a candidate algorithm called as a priori, okay, initially scan the entire data set and generate a item set from 1, 2, 3, 4, 5 like that, and test the each of the condition, and we terminate it when the item set are no longer available. Let us see the example. Now let us say I have a table where I am showing you transaction ID equal to 100 to 900, and I have 5 items I1, 2, 3, 4, 5, bread, butter, milk, umbrella and shoe, and the list of items on the particular ID are like this. Now for the sake of clarity, I just translated the same table into a color form. So if you look at the table right now, the table contain 9 number of transactions. So my D is equal to 9. So my entire database or small database contain 9 number of transactions. So I say mod of D is equal to 9. So we use this illustrate the priori algorithm for finding out the frequent item set. So T100 has I1, I2, I5 and things like that up to T900. Now, let us do a algorithm called as a priori algorithm and see the example. What we do is very simple. Step number 1, in the first iteration of the algorithm, each item set is a member of the set of a one item set called C1. So, I have a candidate set C1 where only one item will be available. So, algorithm simply scan all of the transactions to count the number of occurrences of each of the item. Now, let us do that. So, if I count I1, how many times I1 are coming? So, you can see the brown color 1, 2, 3, 4, 5, 6. So, I have item set I1 coming for 6 number of times. I2 is shown here. So, I2 is coming as 7 number of times. I3 is equal to shown in the magenta color 1, 2, 3, 4, 5, 6. I4 and I5, they are only coming 2 times, I4 here and I4 here, I5 here and I5 here. So, that means I scan the entire data set and make a scan D for and count each number of candidate item set. So, I have one item I1, 2, 3, 4, 5 and their supporting count is 6, 7, 6, 2, 2. So, I got a small another table where I have a item set and the supporting count. Now, from here we eliminate, so compare the candidate support count with the minimum support count. So, I say if I take a item set with minimum of 2, that means in every transaction minimum 2 items should be there. So, if I look at that, then I find that I1 is having a 6, so it is better than that. I2 also 6. I3 is equal to I2 is equal to 7, I3 is equal to 6 and so forth, so on and so forth, with I4 and I5 having 2. That means each of the transactions are supporting my minimum support count equal to 2. So, I4 and I5, though they are having 2, but they are supporting the count. Now, so suppose that minimum supporting count is here, then we go for this. Now, here we are referring the absolute support count because we are using a support count only. So, if I take a relative one, then I have 2 and total number of transactions is equal to 9, then it will become a relative database. So, right now I am taking the absolute value. So, what we do is the set of different one item set L1 can then be determined. It consists of all those candidates where one item satisfies the minimum support value. So, in our example, all the candidates of our C1 satisfy the minimum support value. So, it is all satisfying the minimum support value. So, even 2, 2, 6, 7, 6 are available. So, I get from C1, compare the candidate and I get a L1. Now, after getting L1, what we do is we go for L2. So, let us go for L2. To discover the set of frequent 2 item set L2, the algorithm uses a join of L1 into L1 to generate a candidate set of 2 item set called C2. C2 consists of mod of L1 taken 2 items together as called as a 2 item set. So, note that no candidate are removed from the C1 during the pruning process. We are not going to remove anyone and step becomes easy. Now, let us see here. So, generate C1. So, I have 5 items. So, I start from I1. So, I1 to I2, I1 to I3, I1 to I4, I4 to I1 to I5. So, I have 1, 2, 3, 4. So, I have a 4 support count on this. Similarly, I start with I2, I2 to I3, I2 to I4 and I2 to I5. I have here I3, I4, I3, I5 and I3. Now, if you look at here, then we get a support count and from here we can see that the total number of I1, I2 is 4, 4, 1 and things like that, and there is no relationship between I4 and I5 because there is no I4 and I5 appearing in the transaction database as a 2 item set. So, they are separate. So, I3 and I5 they are appearing only one time. However, I4 and I5 is not available here anyway. So, we put a 0. So, this table C2 is basically coming from the item data set, and for each of the candidate we try to put the minimum support count. Now, after having done this, what we do is compare candidate support count with the minimum support. So, minimum support I have taken 2. Now, when I have taken the minimum support is equal to 2, the last 3 entries, this entry and this entry will go away. So, I have 4, 4, okay, this entry will also go away. So, I have 2, I have 4 and 2, 2. That means out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transactions, I have only 1, 2, 3, 4, 5, 6 transactions which are valid and good for me. So this way I get a L2 item set from the C2 item set. Okay. So this explains you basically the process of getting a minimum support count. Now, so if we go with the three number of supports, okay, I have I1, I2, I3 and I2, I3, okay, after generating the L2, can I go for a C3? From C3, I'll get the L3. So same thing we do it, I1, I2, I3. Okay, so generate C3 candidate from the L2. So I take I1, I2, I3, I1, I2, I5 and all those combinations. So I have a minimum support equal to 2. So I get the value, same exercise I'll do it and I perform operation. So I get 2, 2. So next the transaction D and ascend and support count of each candidate in item 2 set. The set of frequent 2 item set is dependent and then I go with the 3. So when I go with 3, I1, I2, I3, I1, I2, I5, I1, I2, I5 and of course I have all the available. So based on this, now this algorithm is called a priori because the information prior available we are going to use for the next one. So that is the reason it is called as a priori algorithm. So this way I can go for finding out the entire data set and the association rule. So with this what we say that, okay, so based on the a priori property that all subsets of a frequent item set must also be frequent, we can determine that 4 letter candidate cannot be possibly frequently available. So I have only 3 2 available. Okay, so we therefore remove them from C3 and thereby saving the effort of unnecessarily obtaining their count during the subsequent scan from the database. So here we terminate up to L3. So note that we give a candidate K item set, we only need to check only for K minus 1. So I give 2, I need to check, I have 3, I need to check only for 2. Okay, so this is what the algorithm is all about. Okay, so I hope this algorithm makes you clear about how to get the item set and how to make a C1, C2, L1, L2 and L3. So with this I end here. Thank you.